Okay, so today I'd like to talk about factoring polynomials with the help of the rational root theorem. Here you'll notice I have this cubic. Has four terms here, and it's a third degree polynomial in which I can't factor of any of the traditional means by either by grouping or by factoring off a greatest common factor. And so this is a scenario in which the rational root theorem is going to be very, very helpful. I always shorten it up with RRT. The rational root theorem states that if there is a rational root, that it will be a factor of one of these two terms here. So what we have here is we're going to look at all of the factors of 6 divided by all of the factors of 2. And so we can go ahead and list these as such. I'm going to go ahead and list all of the factors of 6 first. All the factors of 6 are 1, 2, 3, and 6, and all the factors of 2 are going to be 1 and 2. And so when we list all of these, this means that I'm going to have 1 over 1 as a possibility, and 1 all over 2. And then I'm going to have 2 all over 1, and I'm going to have 2 all over 2. I'm going to have 3 all over 1, and 3 over 2. And I'm going to have lastly 6 all over 1 and 6 all over 2. All of these also, you can add a plus or minus onto all of them. And so every single one of these, you can see that there are a lot of roots. I'm going to go ahead and shrink this down here a little bit and put this up on to the corner here. So the next step is, once we have all of our rational roots, is that we want to perform synthetic division. And so I'm going to perform synthetic division by just simply taking the coefficients off of the polynomial. I'm going to have 2, -1, -7, and 6. And I'm going to begin with this positive 1 and see what happens here when I go ahead and plug in that 1 here. So let's go ahead and do this. So when I plug in 1, I'm going to go ahead and copy the 2 down. 1 times 2 is 2. I add these when I do synthetic division. That gives me a 1 here. I'm going to multiply and get a 1 here. I'm going to get a -6, and I multiply and I end up with a -6, and you'll notice, oh wow, fantastic. Almost like I made this problem up to work perfectly, huh? Anyway, so what you'll notice here is that 1 is a root because there is no remainder. The remainder is 0. I can rewrite this polynomial now. This 1 is actually going to give me the linear factor of x minus 1. The remainder of this is going to turn into a quadratic. So I will have a 2x squared plus, you could put a 1 there if you'd like. I'm not going to. A 1 minus 6 is my term here. And of course, I want to set this whole thing equal to 0. I have literally gone from here to here now by using both the rational root theorem and synthetic division. The last thing I need to do is I need to factor this term, this quadratic here. And this quadratic you can factor a number of different ways, but one of them is just simply by guess and check. You can also split the middle if you want to. I'm just going to go ahead and do this through guess and check. So I know that 2x squared can only be broken up as 2x times x. And if I start playing with this here, I can very quickly see that I'm going to need to multiply my 6 here is going to have to be either a 1 and a 6 or a 2 and a 3. With a little bit of work, I play with this here. You can see that I'm going to end up with a -3 here and a +2 here. We can check this. 2x times x gives me 2x squared. 2x times 2 gives me a 4x. -3 times x gives me a -3x, so 4 minus 3x will give me 1x. And lastly, -3 times +2 is 6. I'm also going to copy down the x minus 1, and that's going to go ahead and finish off this factoring completely, all down to linear terms, by using both the rational root theorem and synthetic division to help us out.